Let's solve this step by step. We have two blocks connected by a string being pulled across a frictionless surface. First, let's label the masses of our blocks right on the diagram so we can visualize them easily. Block X is 3 kilograms, and block Y is 5 kilograms. To find the tension in the string between them, it helps to first figure out how fast the whole system is accelerating. Let's treat both blocks as a single combined object. The total mass is just the sum of the two blocks. The only external horizontal force pulling this entire 8-kilogram system is the 12 Newton force. On the right. Using Newton's second law, we can calculate the acceleration of the whole system by dividing the net force by the total mass. Now that we know both blocks are accelerating at 1.5 meters per second squared, we can find the tension in the connecting string. Let's focus our attention entirely on block X. What is pulling block X forward? The only horizontal force acting on it is the tension from the string. Let's draw that force vector. Since tension is the net force on block X, we can apply Newton's second law again, but this time only to block X. We multiply its mass by the acceleration we just found, the tension. In the string is 4.5 newtons, which perfectly matches option C.